Hello, everyone. Before we begin, I'd like to make two announcements. If you won anything at the yesterday's auction, you could go downstairs to the reception desk to pick them up. The reception desks will be closing soon, so I would highly suggest after the talk that you go immediately and pick it up. The next announcement is about tomorrow we'll begin the development sprints. The development sprints will be held here at the Palais de Congrès. If you would like to be part of it, it's open to everyone. And if you have any ideas, I would suggest you announce them at the reception desk so that they could be announced for tomorrow's development sprint. So our final speaker of the day, I'd like to introduce Brad Angell. Brad Angell will be talking to us about employing Python to report real-time resource fills to operation managers.
Thank you. Thanks, everyone. I didn't know if closing would be good or bad, but I think it's great. So let's go. I want to have a word of caution is that I'm not a programmer. I'm actually trained in law and architecture, but I got kind of put into a position where we really had to employ Python to do a project we're doing at UC Santa Cruz. So for those that don't know, UC Santa Cruz is the University of California at Santa Cruz. We're about an hour away from San Francisco, south on the Central Coast. This is a picture of one of our dumpsters that gets a Monterey Bay view of the ocean, which is really nice. There on the bottom left corner is our happy banana slug, which is the mascot at the university. And then the rest of the campus has a lot of redwoods and is quite beautiful. Our dumpsters, of course, get to live under the shade of these magnificent trees. Here, can you see it? This is kind of a topography graph of how, topography map, I'm sorry, of the actual campus. And I guess the topography lines are a little bit whited out, but you can see that we're very hilly, and it's a constant hillside for the entire campus. We run a fleet of about 10 trucks. We have on the left is what you call a front loader, in the middle is what you call a roll-off box, and then on the right is a box truck. We have 10 trucks all. We have roughly 300 dumpsters that we run on campus. We're all in-house. We're very robust and take care of we self-haul, they say. At the bottom is our own sort line. We're one of the only UC schools to have one. And then on the right are some of the bins we have to maintain and to work on. And there's roughly 300 bins, or bin sets, so to speak, that we have to run, which takes a lot of labor. So for those that don't know, in the state of California, all the municipalities and counties have to get to what they call 75% landfill diversion by 2020. That means that only 25% of all the waste that's produced in the state can go into landfills. But for the UC schools, the 10 of us, we have to hit, we have a goal to hit zero waste, which means less than 5% waste by the year 2020 in the same time frame. So those 10 schools we're really working hard. This is a graphic of how our waste stream has worked in the past, since 2000, almost 10 years. And you can see at the very right-hand corner, the red line is refuse, and then the dark yellow line is our diversion rate right now, 62%. So even though we were supposed to hit 75% last year, we are far from that in our operations, and we're also very far from a 2020, a 6-year goal of hitting zero waste. So we're having to think bigger. What we did when I started 2 years ago, like a few weeks before I started, they installed what we call the load band system, which actually weighs our refuse, cardboard, and other materials as it's being picked up. This allows us to actually know which customers have deposited what materials where, and we can start doing data analysis on that. So we have been doing data analysis. This is last year, fiscal year 2012, 2013, and we can find our 4 worst refuse users. We can pinpoint them and say, okay, the big tall one is family student housing, and we say to them, hey, we haven't really talked to them yet, but we know that that's where our waste problems are, and we're going to have to really, those are the big fish, so to speak. So we have a lot of pressure to increase our process capacity. Even though we are at about 70%, we really have a difficulty in achieving 95% because most of that stream has to come from organics. So right now we have about 38% is on refuse, about 15% is cardboard, another 15 is sorted recycle. But this other 30% that is going to come from refuse is your soiled paper, your food waste, mostly the stuff. If you look around in this conference center, you notice there's not an organic bin. But if you go to San Francisco, a lot of times they collect their soiled paper and they collect their food waste. Well, San Francisco, Vancouver are some of the only cities that are actually have taken this animal on. And all the UCs are going to have to do it. We're all trying to figure it out, and it's difficult. Another thing I wanted to make sure and mention here is that since 2008, since we had our Great Recession, I don't know if it's all the UCs, but definitely our UC, they don't want to hire anyone. They want to keep labor at the minimum, that 2008, 2009 level, where we barely have enough people to drive the trucks, much less add capacity to what we're doing. And even like my position, which was full-time with overtime sometimes, I'm a part-time at best. I'm part-time. So that's a big issue. We have to figure out how to do this whole new stream with basically the same labor. So I had no idea I was going to be getting into this when I got this job, but now I'm like, this whole system has to change in order to achieve what we're looking for. If you look at what they do in San Francisco, what they're doing in Vancouver, what they do probably here, everything is billed and money is made based on largely servicing empty dumpsters. The Loadman has, the other program I'm talking about, has an entire a graphics metrics analysis tool that tells you if you have too much density in your dumpsters. And if you have too much density, then you have a problem client. That means that they're putting too much waste in. Well, that means that they're covering their labor by servicing empty dumpsters. But for us, when we have a shortage of labor, we would like to flip that and have every dumpster as full as possible when we pick it up, which is different than almost anyone else out there. And so that's when we started thinking about, well, how do we do this? If we can't do just a traditional route, what do we do? And we were inspired, or I was inspired, by, of course, the Internet of Things type movement, I guess you could call it. And we also had a demonstration by Big Belly, which is the dumpster on the left, or the canister on the left. So Big Belly, they will come to your community. They've done Boston University. I don't know if they have any universities on the West Coast or in Canada. But they'll come to you and they'll say, okay, we can basically cut out 90% of your waste pickup from these bins using this their own on-demand technology. And when we talked to them, we're like, well, do you have this for dumpsters? Because we don't really have an issue with bins. We have an issue with dumpsters. And they were like, no, we don't have that for a couple of years. So we decided to do it ourselves. And what we did is we talked to different kind of companies, Internet of Things kind of companies. And we came to Digi was the one that was very cooperative with us. And they had somebody that they put their actual communication devices in. This is a Massa sonar, M3 sonar. And they said, this would be great for your test pilot. And it runs on our, the communicative devices. And you can get one tomorrow. I mean, they're expensive, but we were like, okay, let's try it out. And this one, so what we did is we actually installed, well, first I had it installed on my home, my office trash can to see if it even worked, and it did. So then we put it on a dumpster that's about 15 feet from my office, and that's what it looks like. But when I installed it, all we really had is the data was being delivered to Digi's proprietary cloud location. And they could do some graphics for us and things like that, but it was pretty intense for an operator or somebody that's managing a crew to have to go to this and try to figure out how to decipher it. It wasn't going to work. We needed something much more pedestrian, so to speak, or user level. So I was talking about this. So here was the concept that I had originally thought of and thought I could handle on my own to actually deliver this. And I had no idea what Python was at the time. So we would have the dumpster. That's the actual dumpster with the sonar on it. And it would talk to some sort of interface. I thought the cloud could do it, but it didn't. And then it would put it on the website so my heavy equipment manager could look at it. Well, that didn't work out. What we ended up doing is we had an intern come in. not an intern, a student worker, and he had taken a single class in Python the semester before. And I was talking to him. He was doing data entry for us because he was kind of having a hard time with the recycle crew. So they kind of threw him on me, and typical kind of like developer type kid. And so he came in and he was like, "Oh, I'd love to help you out." So this is the kind of schematic we came up with. And we have the sonar talks to a gateway. I don't know if anybody's used these wireless systems, but the sonar talks to a gateway. The gateway puts it on the cloud, and then from the cloud, my student worker Dylan actually wrote a Python script that would retrieve the information from the cloud, and then it would deposit it in 2 spots. It would put it on a text file for me, and then an Excel spreadsheet, so we would have a record of every sonar reading. And what I did, I grew up, I went to college in the 90s, so I knew enough HTML to get us by on creating a website that would actually show whatever is on this text file that's being updated with each sonar reading. So that's kind of the way it worked out. So that's what we ended up with. We have a website that I wrote on the left, and we ended up with 2 files. And we were able to use the website. I could check it every hour or whenever it was updated. And then I could run out to the dumpster, see if it's actually working or not. And it worked for the most part. And we were getting great data from it. So this is how the data kind of looks after using this for, 2 months, I believe? Yeah. So we already had our loadman data, which is the gray line, and it's telling us how much weight is being pulled or picked up every pickup from the dumpster. So we have the bottom, you see 66 and 218. And then the green line is the actual volume, how much the sonar was actually reading, how much of it was full. So it went from, 5% to 74%. 74% was our highest number. What I thought was interesting or was great about this is that we actually start picking up mistakes. So the red dots across the square dots across the middle, those are our driver logs. So the driver will actually go and in an Excel spreadsheet will mark which dumpsters they've hit. And then I know from this dumpster, which is labeled by specifically that that's when they picked them up. Those are the days. And so you can see on incident A, where I have marked that the driver noted that they actually picked up the dumpster, which means that we actually would bill that dumpster, because we have a recharge system for our clients. But if you look at the sonar and if you look at Loadman, nothing was picked up. So that's obviously a mistake that we picked up with the digital, with the 2 systems. But if you look at B, you'll notice that the sonar dumps out. See how when the lines go all the way to the bottom, that means that the volume is empty. The sonar dumped out, and then the driver noted that they actually picked up, but Loadman didn't pick it up. So you can kind of start double checking what's working and what's not working. On the far right, it also gave us, you could see this straight line, which was never good. And that was when we had a battery failure for, I think, almost a week. And we didn't realize it until we kind of when it was working, we kind of quit looking at it and wanted to just come back and see if it's still working. And that was when we found out we had a battery. So this kind of has huge implications on an the whole system of waste hauling or resource recovery. So I can probably go through the different, where people are from. So there's the traditional system is what you call a volumetric service-oriented resource recovery. That's when you're, like probably everybody's used to, you have a bin and it's a particular size. It's one yard, or it's if you're a household, it's this size. They charge you so many dollars per month, whatever. I think they charge us $55 to service it on a weekly basis. So that's a volumetric system. That's the dominant system throughout at least North America. And to go to zero waste with that system can be very troublesome. I think San Francisco and East Bay are working on it with Recology. And what they have done is they'll pick up, they charge you for the refuse picked up, and then they will complementary, they kind of like add in the recycling and the other streams in addition, but they base all their money on the refuse. But what happens is you keep having to increase your refuse charge, and you have to make the volume smaller as you get closer to zero waste. So it's like a it's kind of an illogical system to continue to follow. What other cities like Vancouver have done is they, at least the city of Vancouver's own buildings, they have set up a contract with their hauler, Waste Management, based on performance. They say, okay, for the last 10 years, we had this much volume, and you charged us this much money, and we're going to pay you for the next 10 years based on that allocation of cash, how much it cost us. And you will service us to zero waste, and then we'll come to the table again and once the contract's over. But that's still difficult because that's a very difficult thing to go by, is to say, well, historically we had this much volume, and we want to keep making money based on that volume. But does that really directly induce you to go to zero waste? How does that work? You almost have to be with a community that really wants to do it. They're not going to do it because of financial reasons. So what we're proposing, and we don't know if anybody else is doing this, but we're proposing a weight-based resource recovery system where we're going to charge you by the pound. Right now we're thinking it's going to be about 22 cents a pound for refuse pickup, and we'll charge you less for our recycling pickup. And we'll be able to monitor that with our loadman system. We'll be able to say, okay, we picked up 700 pounds yesterday from yours, so that's 700 times 22 cents you owe us for the next bill. But the only way that really works for us operationally, because ideally, everyone will discontinue using refuse. They will go down to the 5%, and they'll need us less, or they'll need us in a different way. And so what that works for us is we have to find efficiencies in our operations to make it so that we still can keep a budget that is cash positive, so to speak. So in order to do that, that's where the smart dumpster comes in. We will only pick it up if it's full or after a 2-week time period, and then we can use our guys for other, the organics line that we need to introduce, our cardboard, all the other diversion activities that are necessary that we don't really have time to do right now because we're spending so much time picking up empty dumpsters. So our smart dumpster was successful. We loved it. It would work. We were able to say, okay, the script worked. We had a record of how full it got, how much we could reduce our pickups based on the actual weight that was in, or the actual volume when it was full. And so we found a company out of San Francisco, found us and asked us if we would like to be one of their first clients. And they're a hardware company at an incubator in San Francisco that are actually we're kind of like building these, or proposing building one on their own. And they're called Compology. And their system isn't, it's their proprietary system, so I can't really talk about it much more, other than they've kind of realized the dashboard that we had been talking about for almost a year and a half. And this is what it looks like. And our actual guys, we have a third of our refuse dumpsters are rigged with their sensors, and we use them now every day to see which ones to pick up of the 43 when they're full. Before we thought 75% would be good, and now we're realizing that if it's about 65%, by the time we pick it up, it's full and ready to be hauled. But our relationship with Compology, our comfort with going on with such a huge contract with these guys that are very new to the business. I mean, I don't even know if they really understand how hauling works. I mean, I didn't understand it 3 years ago, but we were on board with all this because of that little Python script that was written that gave us the daily reading of what's going on, and to be able to bring the real world values to our desk, and to our own note system. So there were some different concerns and drawbacks with the implementation. First, I already showed the battery life, and now as we're going into at least a third of the campus, and maybe by next year have all of campus, I'm still worried about the errors because of battery life. I know that's not a big deal with Python, but these are like the reality of bridging the software side with the actual hardware in the field. Second is that we've always been worried about communications. I don't know if anybody has heard about the big controversy with the smart meters on PG&E's energy, your electricity box, or electricity meter. Well, in Santa Cruz, everyone is extremely worried that they're causing cancer. So a lot of times, whenever you're proposing these new technologies, especially with communications, if it uses a cell service or a cellular service, then we start getting people that are upset and will show up and do things that are, difficult to operate around. So the thing that we loved about the Digi is the radio frequency, which is not on the radar as being a bad thing. And the recent topology meter sensors right now are a cell system, and we're hoping that they'll go to Wi-Fi. That was another thing that we thought was a big deal. So that's something to think about if you're actually trying to propose or work on these type of projects. The third thing is that as we start doing more zero waste actions, like these are our new canisters that we're going to probably deploy next year throughout the next 4 years, is that when you start bringing the technology in, when we had this, even the one sensor, when I had it on the dumpster close to my office, everyone started talking about it. All the operators, the building managers. And now that we have them on 43, people are actually afraid of the sensors, which is, I mean, because the technology is just like this weird thing. They worry it's like a big brother type thing. And so one thing is that we were worried about vandalism because the sensors are out there. I mean, we know they're not destructible by the waste, but we're worried about people with just actually having bats and doing things like that. But the second thing that was actually positive about it was that people felt like they were being watched. So they actually diverted a lot better. It's almost like the camera that doesn't work on the wall. Well, this whole thing was like, oh, we're being watched. So people were actually pulling diversion materials out of the dumpster after they saw the camera. They would throw it in, and they would see the camera, and then they'd pull it out. So it's been really wild on how much difference this is making. But on this slide, I wanted to make sure and make a note that the benefit of actually moving forward with this type of activity could have extremely positive economic outcomes. So I want to see what the exact number was. So I did the numbers, and if we actually apply this smart dumpster to the entire campus, all 250 dumpsters we have on campus, and then we actually do the savings I expect based on the loadman data and based on our single smart dumpster. We expect to like reduce at least 2, possibly. Well, we're only gonna have to do 1 out of every 3 pickups or services we've had to do in the past, and that equates to $263,000 worth of labor. That's labor alone. That's not gas. That's not tires. That's not all other stuff. So doing this type of activity actually could have extremely positive economic benefits to people like me, operators. And for us, it's not that we want to get efficient to lay people off, which I heard happens at other places. For us, we just need more labor capacity to do the other streams, you know. So that's why I think everybody's on board so far. And then next, so we've been successful with the smart dumpster and with this whole idea. But at all the UCs, we all have our sustainability plans, and everyone on my side is like, how the heck, you know, do we start really changing behavior? And that's what the great thing about the smart dumpster was, is it had immediate changes to behavior with the drivers, for one, and then also people knew that they were doing something. They were being watched to make sure that they do the right thing. Well, these are all the different topics that we have to cover in the sustainability plan by 2020. We have, I don't know if anybody is familiar with California's drought. I mean, we're turning spigots off right now on campus. And they have to make guesstimates. They don't have exact meter numbers because it takes time to gather all the numbers. And so if we were water is the one I think would be the next low fruit to actually put the sensors on. And energy should be something we should be able to do quickly because you already have kind of the smart meter devices on most of them. So there's the meters are out there, and then there's us sitting operators at the desk, but it's very difficult. That bridge that is critical that Python programmers could provide is definitely something that I'm trying to that's why I wanted to talk today, is to say, hey, you know, we really need help from an operator side to make this happen so that we can actually give dashboard readings on all of the different categories that we have to meet. And then even in a past life, I actually did California Environmental Quality Act activities, and you have your mitigation issues. You have to constantly monitor things if you're, you know, disturbing them, so to speak. And this is a total another area that the Python type of bringing the hardware to the software and bringing it together and computate, you know, in good computation could really be helpful. And I don't feel like anyone is really addressing it. I felt like when we did the smart dumpster, we had a hard time getting really any help I expected, I guess. Maybe I didn't reach out as well, but I'm working on it. So I think that was the main thing I just wanted to say, is that I feel like it's really important that professionals like me, we need your partnership in moving forward. And this is a whole growth area that's beyond just the strict software type of data management. We actually I mean, we have things that we could work on, and I'm looking forward to a professional career with you. Okay, I wanted to make sure and thank my boss, Roger Edberg, because he was the one that was totally pro all this stuff, and then my student worker, Dylan. And I'm ready for questions or any listeners or comments. Thank you.
So if you have any questions, you just could approach the mic.
So I have, there we go. I have more of a comment. So there's a hackathon coming up on May 10th in San Francisco, New York, and Sao Paulo that's called EcoHack. And it's specifically for projects just like this. And so you can bring it there, and there'll be coders from like Google and other fancy places who are coming exactly to work on projects like this.
Oh, cool.
So anyone else like in any of those cities, highly encourage you to bring your projects, and it'll be a lot of fun. I'm working on the Python for Clean Energy project, and we're going to be there.
Okay, cool. Yeah. That's next week?
May 10th.
May 10th. Okay,
Yeah.
good.
EcoHack.
EcoHack, yeah. Okay, good. Yeah, definitely. Good. No, thank you.